Okay, we are streaming. All right, so today we're talking about, first we're looking at 4-6. We're talking about isosceles and equilateral triangles, okay? Now, as a reminder, isosceles triangles are what kind of triangles? What do they look like? Two sides are the same, right? That's what isosceles triangles look like. Two sides are the same. Isosceles. Remember I told you the little story about pizza? This looks like a slice of pizza, and pizza used to, back in the day, you could get two sauces. So two sauces, two sides, isosceles. That's how you can remember it. Okay? Now, if you have an isosceles triangle, and you have these two sides the same, these two angles, or we call them their base angles, are also going to be congruent to each other. All right? Now let's talk about equilateral. Equilateral. Now what does equilateral mean? All three sides are the same. That's pretty good, isn't it? I'm proud of myself. I've got two good triangles going on here. Now, what?
It looks like a Dorito.
Oh, like a Dorito. My Doritos were never that perfect. Okay. Now, what also is true if all three sides are the same? All three angles are the same. And they're all 60 degrees. No matter how big that triangle is or what, they're all 360. Because if you have a sum of 180 and you divide that by 3, all three of them have to be 60. Now, that's not the case over here when we're talking about isosceles triangles. These two angles could be any number of things. So this is what we standardly think of with an isosceles triangle. But an isosceles triangle could look like this, where these are congruent. This is congruent to this, right? It could be all spread out like that. It could be obtuse. It could be acute. Okay, so we're going to take this knowledge and we're going to apply it to some problems, all right? What? Okay, so it says if AC is congruent to AD. So let's look at that. AC, actually, I'm going to do a thing to make my life a little bit easier. Y'all hold on just a second, okay? Here's my belly pepper. Oh my gosh. These days, I'm going to actually get my crap organized so I can find it when I'm looking for it. It would bother me.
Well, here we go.
Okay. So I'm doing this just because I have to do a lot of marking on this, and I don't want it to be super confusing. So we've got this triangle right here, right? A, C, D. This is a B. This is an E. Okay? And it says if AC is congruent to AD. So AC, we're talking about this piece right here. And then we're talking about this piece right here. Right? Do you follow what I'm saying? So if I discount everything inside there, I don't pay attention to any of this stuff inside there. If I just look at this triangle right here, and I just said that AC is congruent to AD. What do you know about that triangle right now? You know it's isosceles because it has two congruent sides, right? Now, what angles are going to be congruent in that triangle based on those two sides being congruent? Angle C is going to be congruent to angle D, those base angles. So our answer right here is going to be angle C is congruent to angle D. Okay, so if we go back and look at this again, the next one says segment BE is congruent to segment BC. So segment BE, that's this right here, is congruent to BC. That's that right there. What triangle do y'all think they're talking about? They're talking about an isosceles triangle, but what would we name that triangle in this diagram? Okay. Hey, you need to pick up both of the worksheets that are sitting over there, Samuel.
Did you drive here?
You drove to school? First time?
Damn.
Dang,
Oh,
what's
dang.
your mouth?
Hey.
I mean, Woody.
Was this your very first time to drive
Did
to
you
school?
bring the car seat?
Okay. All right, y'all are missing what I'm trying to ask. So I'm going to go back to this diagram right here for a second. Okay? They told us that this angle or this side and this side is congruent. That's what they told us. Those two segments are part of what triangle? What is the triangle that they are part of? B, C, E. We're talking about that triangle, right? All the rest of this don't matter. Nothing else in there matters. The only thing we're talking about is this triangle. So when they're asking us which angles are congruent based on that information they gave us, which two angles are we discussing being congruent? Yes and no. So we're talking about this angle and this angle, and we can call, but we can't call them C and E, unfortunately. Why can we not call them C and E? Yeah, there's two angles there, and we actually goofed up over here. We shouldn't have done that right there. But we can't call this angle E because there's 3 there. We can't call this angle C because there's 2 there. So we're going to have to actually name those angles. So we're going to have to name this one here. Like, what would we name it? What's 3 points? B, E, C. So we would say angle B, E, C is congruent to what? Angle BCE. Angle BCE. BCE. Y'all see it? Okay, you guys try 3 and 4 and let's see if y'all can figure it out, okay? 3 and 4, they're going the other way. They're giving you angle measures that are congruent, and they're asking you to find the congruent segments. So let's see if you can do it. We're just going to leave it with angle C and angle D, but just know that we really shouldn't have put that for angle C. We should have, angle C, we should have named like ACD, because there's 2 angles there. Okay, so let's look at 3. If they tell you that these 2 angles are congruent, what are the segments that must be congruent? BE and EA. So we would say BE is congruent to EA. Right? It's
Yeah.
in the
Every time you see people, you gotta honestly.
I mean, you have to. It's like a rule.
Yeah, you know that. Hey, sports. It's just a game. You gotta say it every time.
You have to say it every time.
That's a rule.
It's a rule.
Rob, have you never played Madden before? You ever played 2K? 5 seconds on
Any sport game.
Any sports game. For me,
boy.
no, probably FIFA.
Soccer. What FIFA you like?
Oh, I don't play. I don't play.
I play Madden. I'm so good.
Maybe Madden.
So good.
I play basketball.
You good?
No.
Show me your form.
I have beautiful form. I just have no hand and eye coordination. I have beautiful form. Okay. CED. CED. That's this angle, right? CDE. CDE. That's this angle. So which segments are congruent? CD is congruent to EC. Perfect. Okay. Let's look at 5 and 6. Hey guys, come on. Get it together. So, in this diagram, which sides are they telling us are congruent? They're saying that AB is congruent to AC. So what does that tell us? What do we know because of that? We know that angle C and angle B must be congruent. So what does that mean about this angle right here? It's 60. If we know that angle, could we find this angle if we wanted to? Yes, we could. Now, is that part of what our question is? No, because the question says to find angle ABC. So what is the measure of angle ABC? 60. So we're through with that one because we don't need to find the other one. But we could if we wanted to. How would we find this missing angle right here? 180. 120 from 180. Okay, so look at this one. They gave us 40 right here, right? They gave us 40. What do we know about these two sides? So what does that tell us about these two angles? They're the same. Hey, individual conversations need to stop. Those two angles have to be the same, right?
180 minus 40 and then divide that by 2.
So if we take this 40 away, that gives us 140. That means that D and F together have to be 140, right? So if we take that 140 and we divide that by 2, what do we get? So angle D and angle F both have to be 70 degrees. Okay, so based on this picture, what do we know? Those two angles are the same, which tells us what? So, hey, this information is not about the angles. Y'all know that, right? What is that information about? The sides. But what do we know about the sides? The sides. The sides are equal for what reason? If those angles are equal, what does that tell us about these two sides? They're the same. What kind of triangle is that? Isosceles. So if these two sides are the same, we can set up a little equation that looks like this, right? And then we can solve that little equation. What would you do to solve that equation? Subtract 2x. And you could. That would be fine. It's not what I would do, but it wouldn't be wrong. Now what? So what did we figure out x is?
14.
X is 14. Now, if the question was, how long are the sides, or the two sides, right? Are we done if that was the question? No, we'd have to plug that in. That wasn't the question. But if it was the question, we would have to take that 14 and plug it in, right? Okay, look at this one. What do you know based on this information?
It's a right angle.
That's a right angle. Okay, what else do we know?
It's a right angle.
Two sides are the same, which means what? It's isosceles. If it's isosceles and two sides are the same, what else is the same? Angles. Which ones? These two bottom ones. So if this is 90, what do we know about these two angles? Besides them being the same. What do we know about all three angles? They add up to 180. All three angles add up to 180. So if this angle is 90, what do these two have to be? Together. They have to be 90. They have to be 90, right? If this one is 90 by itself, what do these two have to be together?
45.
Together. 90. Now that doesn't mean they're 45. It could mean they're 45. They would be the same, which means they would be 45, right? So what do we know about that angle right there? It's 45 degrees. So we could do 2x plus 3 is equal to 45. Now there's a bunch of different ways we could have done this problem. This is just one of them, okay? But do y'all see how we thought through what that angle had to be? Do y'all see how we got there to that point that it must be 45? So what is x? X 21. All right. I'm going to give you guys about 2 minutes to see if you can write this 2-column proof. I want you to try.
Another first one. Give it. I got to give it part. That's it. I got to give it. That's all. All right. I'll move it.
Ruby, what time is it?
41.
Can you let me know when it's 9:20? It's been okay. All right.
We do us a favor in engineering class.
What is it?
We moved this yesterday and we get Monday.
You're going to get through to Monday.
Okay. We got 12 here.
I don't remember what I was going to say. Okay. Do you have anything down? Have you tried anything? Does anybody think they have it?
I only got 2.
All right. So this whole learning how to write proofs thing is something we're going to be doing all year long, right? We're learning how to write these proofs. And of course, like Luke said, you always start with what? Given. So we're going to write that CD is congruent to CG. Now, if you see a textbook proof, they'll write all the given information down first. I don't like to do that. I like to take one piece of given information, and then if that one piece of given information tells me something else, I like to put that in. To me, it makes it make more sense, okay? So if they tell me that CD is congruent to CG, that's that right there, what does that tell me? What does that tell me with that triangle? It's isosceles. So we would say triangle CDG is isosceles. Now, how do we know it? What's our reason? Definition of isosceles. Now, what does knowing that that triangle is isosceles also tell us? What else do we know? Which two angles are the same? D and can we just put D and G this time? Can we just say angle D and is congruent to angle G? How do we know it? Because it's isosceles. So I would say like base angles of isosceles. You could just put isosceles as fine. Okay? So we know that this angle is congruent to this angle. That's important information, right? Okay, then they tell us that DE is congruent to GF. So let's write that down. DE is congruent to GF. How do we know that? Given. Now, that right there doesn't do anything for us as far as telling us anything else, right? But y'all notice that there's more than one triangle in this picture. How many triangles are in this picture? There's 4. There's the big one, right? Then there's these 3 little ones. Technically, there's more than that, but I want to get into those overlapping ones, right? And do y'all see this triangle and this triangle right here? Y'all see those? Do y'all know that we just proved those 2 little triangles are congruent to each other? How did we do it? Side, angle, side. So we just proved that triangle CDE is congruent to triangle CGF based on side, angle, side. Y'all see how we did that? Now, if we know that those 2 triangles are congruent, what do we know about their parts? They're all equivalent. They're all congruent. So what does that mean about CE and CF? Because of? CPCTC. Yep. Okay, y'all see how that proof works? We're just talking about, hey, we know this, so that means we know this and this and this, right? We know this, so that means we know this and this and this. If we put all of this together, that makes this true. Y'all see what that how that works? Okay. Let's look at 4-7. Okay, you learned this stuff right here a long time ago. Thank you. That is perfect. Thank you. All right. Transformations are when you move something. And we are talking today about what are known as rigid transformations. And rigid transformations just means that the shape doesn't change in any way. It just shifts. It just moves around. Okay? A non-rigid transformation would be changing the size of the shape. We're not changing the size of the shape. We're just changing where it's located. That's what a rigid transformation is. You hate it? Okay. Do you remember what rotation means? You rotate it. That means you do like this, right? Now, you probably have mostly done rotations around the origin, where you're using the origin as your point of rotation. But you can actually rotate around any point. It doesn't have to be around the origin. You can say, let's rotate it around the point of 2, 5 if you want to. Okay? What are translations? What's a translation?
It's more like on top of each other and they're facing the same thing.
You slide it. So I think the word that y'all learn when you're little is slide.
I don't like that.
I think that's what y'all learn is slide. Maybe you learn shift. Shift. Okay. A translation, you're just moving it up, down, left, right. Okay. What is reflection?
Reflected over
Number 2.
what is it called? The axis.
You reflect it. Now, what y'all have done so far is reflecting over axes, right? But you can reflect over a line. Like we could say reflect this over y equals x. And so you would reflect it over that line. And later on this year, we're going to get a lot deeper into that. But right now today, we're just going to identify them, okay? So what did y'all say this one is? What are we doing right here? This one's a rotation.
Reflection.
What's this one right here? Reflection.
Translation.
And what's this last one? A reflection. Okay, let's look at these two down here at the bottom. It says graph each pair of triangles with the given vertices, then identify the transformation and verify that it's a congruence transformation. Okay, they graph that. I hate when they do this. They say to do something, but then they go ahead and do it. And then we're all left to be like, what am I supposed to do? Well, they already graphed it. So you don't have to graph it, right? What transformation is going on right there? What's happening? That's a rotation.
That's all we gotta say.
Okay? Actually, we're going to do one more thing, but we're going to come back to that in a second. Okay? What's happening here? A translation. Now, how could we prove that it's a congruent transformation? That's possible. So we could use the slope of all the lines to see if they have the same slope. But is that going to work if we have a rotation? That's not going to work if we have a rotation, is it? Okay. When they're talking about it being a congruence transformation, what's important for it to be a congruence transformation? What has to be going down they got to be the same. So if we have this guy right here and we have this guy right here, the points are in different places, but we need these two to be the same, right? We need them to be the same size. Now, what is one thing that we know about triangles that we can tell that they're the same? I said that really weirdly. Let me try it again. What is one of our congruence theorems that we could tell that these two triangles are the same with? Okay, what are all of our congruence theorems? How are we proving triangles are congruent to each other?
Side angle side.
Side angle side.
Side side side.
Side side side.
And you can
Angle side. And angle side angle. Now, 3 of those use an angle. And we don't know nothing about angles on this. But one of those only uses side lengths. And what is something that we could find in the coordinate plane? We do know, but let's pretend like it's not for a minute, okay? But what could you find What could you find in a coordinate plane based on math we already know how to do? The distance. Even if this wasn't on a nice, pretty right angle right here where we can count, like we can count that that's 2, and we can count that that's 3, and we can count that that's 2, and we can count that that's 3, right? But even if it wasn't like that, even if it wasn't on those nice little numbers, we can use the distance formula. We can use the distance formula to find out how long it is between those. And if we did it to all 3 sides, which we don't need to do it, we know that AB is congruent to ED, and we know that BC is congruent to EF because we've already labeled them, right? But we need to find how long is AC. So we'll do that math. And we need to find how far or how long it is between DF, right? So we'll do that math. So change in x squared means that we can take the x from A and the x from C and we subtract them and we square it. So what's the x for A? What is our x value at A right there? What they say it was? 1. And then C, what's the x value? 4. So we're going to do 1 minus 4 squared plus, and then what about our y's for those same 2 points? 3, 1. So 3 minus 1 squared. Now we don't have to do this all longhand. We can use our calculator. We can punch it straight into our calculator. 1 minus 4 squared plus 3 minus 1 squared. And we got 3.6. So this one is 3.6. Now we're going to do the exact same thing for this other segment. So we're going from F to D, right? So what is our x values for F and D? 1 and... So we're going to do 1 minus 3 squared plus, and then our y values, negative 4 minus negative 1 squared. Right? 1 minus 3 squared I just did that wrong. And look what we got. So what did we just learn about these 2 triangles? They are the same based on what? How do we know they're the same? What triangle congruence theorem did we just use? Side, side, side. We just proved that these 2 triangles are congruent based on side, side, side and using the distance formula that we already knew. Right? And so we could do the same thing here. We could use the distance formula to determine, are these triangles congruent? What else do you think is special about these 2 triangles right here? What else do you think is special?
Erotic.
These 2 right here.
Oh.
They look isosceles, don't they? So if we did the distance formula and we found that JK was congruent to KL, what would we know about that triangle? It's isosceles, right? So see how you can take one piece of information and learn a lot of different things based on that one piece of information? Okay, so tomorrow you are going to do 4-6 and 4-7 practice. 4-6 practice looks like this, right? 4-7 practice looks like this. You're doing the back. And you're going to turn them in at the end of class. Tomorrow. I mean, you can start working on it if you want to.